Hello, our project is about next day electricity forecasting in the Bay Area, and our team consists of Sanjli, Lore, Uttam, Ataberk, and Matthew.
Electricity demand forecasting enables authorities to better manage the electrical grid. Without forecasting, electrical grids would be less reliable and less secure, potentially leading to not only the loss of many modern-day conveniences, but also the loss of lives. Often, we take the stability of our electrical grid for granted, but with the events like the 2021 Texas power crisis, we are reminded that electricity is not guaranteed, and losing electricity can have severe consequences. Electricity demand forecasting models have their limitations, and like most models, they may lack the robustness to accurately predict demand when unpredictable large-scale events happen, whether they be severe weather events or a global pandemic such as the COVID-19 pandemic. Because these models are relied upon for planning and management of electrical resources, events such as the COVID-19 pandemic can have implications far beyond their direct effects. For this reason and others, it is imperative that electrical demand forecasting models are robust. With the importance of accurate and robust electricity demand forecasting models in mind, the primary aim of this project is to build a model to predict next day electrical energy consumption, specifically in the Bay Area and its surrounding regions. We will build several models using weather and electrical energy demand data and various statistical learning techniques, and then compare their performance. The secondary aim of this project is to assess how well the models perform before and after an unpredictable event that may cause a change in electrical energy consumption, namely the COVID-19 pandemic. We obtained the daily electrical demand data from the U.S. Energy Information Administration for Pacific Gas and Electric, PG&E. We obtained our daily weather data from the U.S. National Oceanic and Atmospheric Administration for the Livermore Municipal Airport Station. This location was selected because it's roughly in the center of PG&E's service area and has nearly 100% complete data for the dates of interest. Here is an overview of our data processing workflow. First, we found sources of raw daily weather and electrical energy demand, aggregated the data, cleaned the data, and addressed any missing data. Next, through exploratory data analysis, we performed some initial feature engineering and feature selection. Lastly, we split the data into training and test sets. Because our models will ultimately be used to predict next day electricity demand, we decided to only include weather variables that would be available in a next day weather forecast. These variables include min and max dry bulb temperature, relative humidity, time of sunrise and sunset, average sustained wind speed and direction, and precipitation information.
After our initial feature selection and engineering, these are the features that we ended up with. The features that will ultimately be used in each model have yet to be decided. Plotted here is the electrical demand for PG&E from July 1st, 2018 to June 18, 2020. Our training set ranged from July 1st, 2018 to December 18, 2019. And our test set ranged from December 19, 2019 to June 18, 2020. Because we are interested in how our models performed before and during COVID-19, we split our test set into two sets, a pre-COVID test set and intra-COVID test set. We selected the California stay-at-home order, which went into effect on March 19, 2020, as the start of our intra-COVID test set. We plan to build a minimum of 4 models, a random walk model as our baseline, and a CEREMO model, random forest model, gradient boosting machines model. We will use mean absolute error and root mean square error as our comparative performance metrics. While we began building models, due to time constraints, these models will not be presented here, but will be in our final report. In summary, our goal is to build models for predicting next day electricity demand in the Bay Area and its surrounding areas, as well as assess how well these models perform before and during the COVID-19 pandemic. We have built a data set containing weather and energy demand data and have performed initial exploratory data analysis and feature engineering and selection. Our next steps are to complete the models, test and compare our models, interpret the results, and summarize our findings in a final report. Thanks for listening.